been attached to. Two equal positive charges Q are fixed on the x-axis, one at positive A and the other at negative A. Point P is a point on the y-axis with coordinates 0, B. So, first thing we need to do for part A is find the electric field at the origin, or point O. So, E equals KQ over A squared. And then A squared. And then we have minus, because that's on the, hold on, that's negative A. Yeah, alright, minus KQ over A squared, because that's negative, that's on the negative x-axis, and this is also positive Q. And then that equals, since these are all the same values, that equals 0. Alright, B. Okay. The electric potential V at the origin. Okay, so V equals KQ over A plus KQ over A. So that equals 2KQ over A. Alright, part C. The magnitude of the electric field at point P. So this up here is point P. So electric field at point P would equal 2KQ over R squared sine theta. Because here you draw your little triangle going like this, and then this would be R, this would be theta. So therefore 2KQ over R squared. And you have the same exact symmetrical triangle on this side, with that being R. So then, to calculate sine of theta, you have A and then B, because that's our B. So you have R squared equals A squared plus B squared. And then, so that's, oh shoot, that's stupid, I didn't need to do that. Erase that, sorry, I messed up. Okay, so then sine theta, you have opposite over hypotenuse. Oh wait, okay, so sine theta equals opposite, which is B, over R. And then to find R, you need R squared equals, sorry, this is backwards, R squared equals A squared plus B squared, and then R equals square root of A squared plus B squared. So then you have E, the electric field at point P, equals 2KQ over R squared, which you can substitute as the square root of A squared plus B squared. And then sine theta, we decided, times B over square root of A squared plus B squared. And then, so then your final answer, E of P, after you simplify it a little bit, would be, so 1/2, so you have two square roots, and square roots is normally like a quantity raised to the 1/2 plus 1/2. Sorry. Ugh. Okay. Basically, it's 3/2 because you're timesing it. So then you're going to have 2KQ B over over A squared plus B squared. 3/2. Alright. And then we go on to part D. I'm just going to erase all of this.
Isn't that square root, not square root? 2K.
Huh?
Isn't that
Oh, sorry. Wait.
this one? Not square root, because it's over R squared.
Oh, yeah, you're right. Sorry.
So that's why it's 3/2.
Yeah, that's why it's 3/2. Sorry, that isn't square rooted because it's R squared. So then you just get rid of the square root and it's A squared plus B squared. There we go. Okay, sorry for making that mistake. I won't do it again. I will do, whatever. Next problem. Okay, so then they want you to find D. So now we have a small particle of charge Q, which is much smaller than the other charge of and mass m is placed at the origin and displaced slightly. So here we have Q. And then released. Assume that the only subsequent forces acting are the electric forces from the two fixed charges Q at x equals positive A and x equals negative A, and that the particle moves only in the xy plane. In each of the following cases, describe briefly the motion of the charged particle after it is released. And then, alright, so for D, the particle it's going to move toward the origin, and then it's going to oscillate back and forth about the origin. So it's going to move, it's just going to go kind of like that about the origin after it moves back towards the origin, because it's displaced slightly off the origin, so how do you spell oscillate? O-S-C-I-L-L-A-T-E. Okay. And then part E. Q is positive and is displaced in the positive y direction. So then for E, I'm just going to erase all of this. Okay, so for part E, the particle is, Q is positive now, so the particle is going to move away from the origin. So, so then you can use the expression like when, for an expression, you're going to have like U equals QV, and then you know that U equals K and K equals 1/2 mv squared, and then, hold on, let's use the other one. So U equals 2kq over A, and then 1/2 mv squared equals 2kq over A, and then you have V after you divide by m and times by 2. You get V equals the square root of 4kq lowercase q over m A. Alright, and then you can take the 2 out, or just leave it as that. Alright, so then you go on to part F. Alright, so for part F, Q, this Q up here, is negative and is displaced in the positive y direction, so it's going up. So it's the same as part E, except that Q is negative. So for part F, it is going to, because it is negative, it is going to move back towards the origin and then oscillate about the origin. So the particle will move towards the origin, then oscillate about the origin. Okay.